Right. So I started the recording, and Lukman, you can take over. You can start. So, welcome everyone. If you remember, our last lecture on Sunday was about Ngram language models, where basically, Ngram is the kind of basic language model where um, language modeling starts, and we want to demonstrate the Ngram language models. And Lukman, who is the course coordinator for this, is here to lead us into today's discussion. Lukman, you can start. Thank you.
Okay, sir. Good evening. Good evening, everyone. So today we are looking at the practical class for the Ngram language models. So the lectures already been given by Dr. Shamsuddin, where he explained what Ngram language models are and the rest. So today we are trying to look at the implementation. So look at the Python implementation of how engrams can be implemented just to have a more intuitive understanding of what engrams are about. So the engrams is about getting the probability of languages using sequence. Like, okay, you have a sentence, you want to be able to quantify based on how they occur in the sentence, how words occur in the sentence, how you can predict, okay, the next word based on how they occur in the sentence. So it's just a simple probabilistic model. So these are what we call natural language processing with probabilistic models. So it's a probability where you use count to be able to generate, okay, this is how this thing. So you use models and you count based on the previous n minus one words. So let's say you have a 1 gram, that means each word is independent. For a bigram, it's based on the previous one word because each of the n gram, you model it based on the previous n minus one words. That's how they are for understanding language probability. So it's all about words that come together, use how words occur in the sentence in normal English, how words come together, and then you use that to model and predict what the occurrence, probability of the occurrence of the next words. So for this, for the practical, the first thing is to set up an import. So I'll try to explain each line of code as we go because I don't know people's. So the understanding is that everybody has covered the other aspects like the normal Python, the machine learning, deep learning, and the rest. So we should all be conversant, but I don't want to make any assumptions. So I'll try to explain each of the lines as we move and then as we run the code cells together. So if you open the code on, open the notebook on Colab, you can see the screen. It starts with the importation. So NumPy, of course, I've annotated is for numerical operations and for the log probabilities. So one good thing about probabilities is that if you have independent occurrences, you can multiply them to get the overall probability. And then with that, we also use the property of logarithms. For anything multiplication, using logarithm, you can convert them to addition. And that's why the computation is easier. Addition is easier than multiplication. So that's why we also employ log probabilities. And then the next one is from collections, import default dict and counter. So this one is for counting. And then default dict and counter. Counter is normal. It just gives you a dictionary you count. For default dict, it's a bit different because it doesn't give a key error. So if you try to call something, it gives you a default value. So that's why it's default dict. And then matplotlib, of course, is for visualization. And then for type, then the next one is typing, import list, dict, and tuple. This is for type hints clarity. So when you're defining your classes and your function, you want to make sure that each of the classes are properly defined, like each of the hint types are properly defined. So you know whether this is a string, this is a list, this is a dictionary, this is a tuple. And then the next one is random. So that one is, of course, you use random for the generation. And then the next thing is the random.seed is for reproducibility. So I want a situation where when we run the code, because we put the same seed, everybody will get the same answer because it's starting from the same seed. Otherwise, without a random seed, people will be getting different answers. as we run, because we are using random as part of the libraries we are using for the practical. And then the next one is the training corpus. So the corpus is just a collection of tests used to train the model. Just let's say we are having a dictionary that we are using to teach our model what the language is, to teach our model to better understand the language. So, and then in this here we use this these tags X and the other second tag, the closing tag S, to mark the sentence boundaries. So it shows where it teaches the model where the sentence starts and where it ends. So for the corpus, it's just a very short one here. We have I am Sam I am, and the rest. I do not like green, eggs, and ham. So this is the corpus. It's just like the collection that you're going to use to train the model. And then here we are trying to print the corpus using enumerate. So of course, enumerate in Python is just to, it gets you the list, and then it gives you a number, and then the item that you're trying, the collection. So each of the items it gives. So normally here it gives the number starting from 1. So if you don't put 1 in the enumerate, it just starts from 0. The default is 0. But if you add 1, then it starts from 1, because normally counting starts at 1, but in Python is 0 base index. So you make it 1 because you want the counting to be normal, natural, just like normal counting. So this is the corpus that we are trying to use, is the text that we are going to use to train our model. It's a simple model, and it's just for illustration to understand what an n-gram does. So the next one is both basic tokenization and counting functions. So all these are linked to the slides that were discussed in the lectures. So tokenization is breaking the text into individual words. So you call them tokens because it's not all times that you divide into words. You can break down into words, and then there are sub words too. And then there's character tokenization, where you even divide the breakdown into alphabets. But here we try to tokenize them easily. So for the first function, tokenize corpus, we just try to tokenize it based on white space. So if you use sentence.split for sentence in corpus, that's a list comprehension. So for each of these, you split. So you have the corpus, which is this sentence, which is this, just 3 sentences for this illustration. And then when you put it here, and this is where our importation of typing, where we imported list and the rest, this shows that the corpus is a list of strings. So it's a list of strings. You have list, and then there are strings, and then it gives the output. The output is also, it returns a list of strings. So at least this, it gives you a hint of, okay, what is the input into the function and the output too. So for the tokenized corpus, the main purpose is you have the corpus, which is like a text that you want to train your model. Is a list of sentences, and you're going to split them into tokens. So, but this one is a simple tokenization where you just split based on white space. So sentence.split for sentence in corpus. This is a list comprehension. And then the next one is, so this list comprehension is just, instead of you to use a for loop and go over it, so you just use a list comprehension where it just gives you the list. The second function is build vocabulary. So you've already tokenized your corpus. You have your list of tokens. So what this returns, this tokenized corpus, is to split each of the sentences into tokens. So you have a list, and you have a list of each of the sentences has turned into a list of tokens. So you have a list of lists, a list of lists is returned. And then the second one is build vocabulary. Build vocabulary from that list of lists that you have is going to give you individual tokens. So you get individual tokens here. So that's the build vocabulary. So here you have vocab is equals to set. So use a set to avoid duplicates. So I try to annotate this as much as possible. Then for tokens and tokenized purpose, vocab.update tokens. So already it's a list of lists. So in each of the lists, you just get the tokens and then update your set. So if there's a duplicate, automatically it eliminates it, because sets cannot have duplicates. And then it returns the sets of the vocabulary, which is a set. So the vocabulary is a list of all, is a set of all your tokens. So each of the tokens, one without repetition. And then the next function is count unigrams. So here is going to count single words, and we use counter from collection to do that. You could do a normal pure Python implementation, but counter makes it easy to do. So you just have your dictionary, and then you put your this thing. So the first thing is a nested for loop for tokens and tokenized corpus for token and tokens. Unigram token is plus equals to 1 and return unigram count. So what this does is just to get you the count of each word occurrence simple. So that's unigram. And then for the bigram is going to count each occurrence of two words together. Each occurrence of two words together. So you still use counter from collection to get the bigram count, and then you do for tokens and tokenized corpus for I in range, length tokens -1. So you get the I range token -1 because you're going to stop at the second to the last token. And then for each of the bigram, you take tokens I and tokens I plus 1. So for the length tokens -1, that's second to the last, you add the final one. So in essence, you're going to get double double, like each of two occurrence. So for in the initial corpus here for the bigrams, that means you're going to get I am, and then the second one will be am Sam. For this one will be Sam I, then it will be I am. And then here will be I do, then do not like green, green eggs, egg and ham. So that's the counting for the bigrams, and the trigrams too. Count trigrams too is the same thing. You have your tokenized corpus, which is a list of strings, and then you also do this thing. And here too, you just make it length tokens -2. So you stop before the last two, because for each token in the trigram, you take the token, and then you take the next token, and then you take the token after that. So you get triples, and then you count them. You count each of the triples. So for this particular, the first sentence here in the corpus, you just do 1, 2, 3. You get all the three, and that's all. It's only one trigram. Here too is the same, only one trigram. And here too, you do a do not, and then do not like green eggs and eggs and ham. So that's the trigrams. So in each of them, you get the grams together, and then here you use the functions together. So as I run the cells, we do that tokenized corpus. So you have the vocabulary size, which is unigrams, and then you have the total unigrams, total bigrams, and total trigrams. So each of them, you use the dictionaries to get you the counts of the trigrams, the unigrams, bigrams, and trigrams. So you use the functions, and then you use them. And then as you go down the notebook, you're also going to implement them together. So some of these things, if you have any question, you can ask as we proceed. If there's anything that's not clear. But for some things, maybe it will take some time after going through the notebook, maybe a person has to go over the notebook again before he truly understands what each uh, what each line of code does, depending on how conversant a person is with Python. So the next one is counts. So we get we display the counts, and then we explain why counts. The reason why we count is because probabilities are estimated from counts. So if they say, okay, what's the probability of getting ahead from, let's say, throwing a dice. So a dice has six faces, so you count. You get one. A head is maybe a one out of throwing a dice. So a dice has six faces, so you have six options. So the probability will be 1/6. So when it comes to probability, use counts to get your probability. Probability of getting a word in a sentence is the count of the word divided by the total words in the sentence. So, and that's why we are getting the count of the unigram, the bigrams, and the trigrams, because that's the models that we are working on, simple models based on probability. Because these are some of the simplest models that we can use for NLP. And in some cases, they work well because they kind of use the probability of what's occurring together. So for unigram counts, we have, so this unigram counts and the rest is, there are dictionaries that unigram counts are these things that you use for, there are already dictionaries that you use for. So the unigram, the counts are dictionaries that you use for your. But I wanted to say the functions. These are count unigrams, count bigrams, and the rest. They return the dictionaries, and dictionaries are the dictionaries of counts. So for this, you get the sum unigram count dot values, bigram counts dot values, and then trigram counts dot values. So as we all know, you have keys. In dictionaries, you have keys to get the keys, dot values to get the values. So if you have a dictionary of values, if you have a dictionary of values, so if you have a dictionary, the values will be the numbers. So you just get the sums. So here the vocabulary size is the length of the vocab, which is 12, and then total unigrams are 20, and then the total bigrams are 17, the total trigrams are 14. So and these are where you put the tokenized corpus. The tokenized corpus that we have here. Firstly, we get the tokenized corpus. So we use all the functions that we explained. So with all the functions that we've defined here, tokenize corpus, build vocabulary, and all of them, and then we count, and then this is everything. We have the vocabulary size of 12, total unigrams of 20, total bigrams of 17, trigrams of 14. And then the next one is here you have the dot item. So you have when you in dictionaries, so as we all know in dictionaries, we have the dictionaries have dot items. Dot items means you're going to get everything like the keys and the values together. That's items. So when you do the sorted unigram counts dot item, you sort them alphabetically. You print the word and the counts. So for the unigram counts, you get the beginning of sentence and the end of sentence markers. There are three of them, and then that's because there are three sentences. Number of eyes in all the everything is three. Number of sum everything is three, and then the everything arm is two and the rest. So for bigram counts, as you can see, there are pairs. The beginning of sentence and I you have two. This beginning of sentence and sum you have one, and then beginning I and arm you have two. And so it's pairs of words together or pairs of tokens, though we tokenize on character on white space. So that's why it's using the space. So for trigram counts, we have a counts of three. So three of them, you have each of them. Most of them are one because the this thing is very our corpus is very small. So the first is the unigram model. So after explaining the unigrams, you have just one. Bigrams, you have pairs of words together, but they have to come next to each other. And then trigrams are three triples of words or tokens together, and they have to come next to each other. And then for unigram model is the simplest language model. It treats each word independently, so there's no context. Probability of word is just the count of the word divided by the total words. So normally it's just you count the word and then divided by the total words. That will give you the probability of your model. And then here you define the unigram model class. The unigram model class where you have the this thing. So of course in Python you to define a class you start with class, the class keyword, and then you write the class name. Then you initiate the class. So this does this dev dunder init self tokenized corpus. So tokenized corpus is what you need to pass in while initiating the model. So anytime you need to define unigram model, you need to add tokenized corpus, which is a list of strings. And then this one is self.unigram counts is equals to count unigrams. Set of self.total count is equals to sum self.unigram count dot values. So you get the unigram counts and then you get the total words because you're going to use them for your probability. And then the next one is probability. So these are the methods in the class. So you calculate probability of the word. So for word 0 and then divided by self dot total was. So in the dictionary, dot get method actually gives you, it looks for the key and gives you the value. If the value doesn't exist, it doesn't return an error. So it just returns the default value you give. So the here is dot get word, and then it returns a default of 0 if the word does not exist. If the word is not there, does not exist in the corpus that you added. And then the next one is log probability. So after getting the probability, you get the logarithm of the probability. So it's just numpy. That's why we imported numpy in the beginning. So you get numpy np.log prob.